All right, this is it. Last video for all our topics. We're looking at just solving some problems with trigonometry. So we're going to use some of that sine law, cosine law, possibly some Pythagorean theorem, possibly some trig ratios. All that stuff could get melded together depending on the situation that you have. So in this case here, what we have to start with is a roof has a base that is 12.8 meters wide, and the rafters, there should be rafters with a T in there, T-E-R-S, rafters, form angles of 48 degrees and 44 degrees to the horizontal. How long are the rafters? So what we have here is a roof. So in general, hopefully you're familiar with a roof, but we're having two lines, something like that. So we have a base here of 12.8, and then the form angles to the horizontal of 48 degrees and 44 degrees. Doesn't matter which side you put these on, you'll still get the same results. So here's our setup. We want to find out how long these rafters are. And so if I look at this, I don't have three sides that I'm working with yet. I'm going to find both sides, but I don't have them yet. I need to find x and y independently. So say let's start with x. We have a side and its angle, but we don't have this matching pair right here. There's something missing. But remember that right triangles have 180 degrees in them. So I can find this value here. So let's call this A. Angle A is equal to 180 degrees minus 48 degrees minus 44 degrees. And when I calculate that out, I'm going to get myself 88. I should be able to do that in my head, but I'm really tired right now. Too many videos in a row. Okay, so our angle is 88 degrees. So now we have a value for that. We can put that in there of 88 degrees. And so now I have an angle and its opposite, and then there's another one here. So I'm going to be able to use the sine law twice for this, is what I'm going to do. So for x, I'm going to do A, what are we doing here? I was right with lowercase. Lowercase a over sine A equals, and we'll just call that, I will call that one B, call that one C. So B over sine B. Start with that pair. So A over sine A, so I have 12.8 over sine 88 equals x over sine 44. So let's calculate this all out here. Convert my sines into decimals first. So sine 88 is going to give me 0.9994, and then sine 44 is going to give me 0.6947. And so if I just finish this up over on this side, 12.8 divided by 0.9994 is going to give me 12.8077. And that equals x over 0.6947. And then I take that, multiply it on this side, so 12.8077 times 0.6947 equals x. And we multiply those out to get ourselves a raftered length of 8.9. About 8.9 there. So there's one. Then I got to find y. Same deal. I'm going to use my A over sine A again. But this time I'm going to do C over sine C. And that'll get that other pair. So I just fill in my values that I know. 12.8 over sine 88 equals y over sine 48. Now, to cheat a little bit, we already figured out this side right here. This is the same. This here is the same as this, so it's just going to equal 12.8077. And then y over sine 48. So to finish that off, 12.8077 equals y over sine 48 is going to give me 0.74331. So now I can multiply these two here, and that'll give me my y value. And that's going to give me a rafter length of 9.5. So there's my two rafter lengths. So again, word problems, you're drawing diagrams. In the case of a sine law, if there's a missing angle, if you have two angles, you can always find the third one by doing 180 minus the other two. And then we were able to set up our sine law here, and we just used it twice to calculate. So unfortunately, with some of these trig questions, you may have to do the sine law and the cosine law. You might have to do multiple things. You might have to use some trig ratios. You might have to use Pythagorean theorem. You might have to use 2, 3 things to calculate everything when it's all said and done. Most of the time, you'll probably be doing 2 things, maybe a subtraction as a third. Okay, one more. We have a baseball diamond is a square with 30-meter sides. The pitcher's mound is 30 meters from home. That should be 20 meters, sorry. 20 meters. Rewrite that. 20 meters from home plate on a diagonal between second base and home. How far is first base from the pitcher's mound? So we got a baseball diamond. So we know it's roughly something like that. The square sides are 30 meters. So all these sides are 30 meters. And then on the diagonal, between home and second, right, because it goes home, first, second, third. So on the diagonal between home and second is the pitcher's mound about 20 meters away. So somewhere around here, 20 meters is the pitcher's mound, and we want to know this distance here. So we're looking for this triangle. So I'm going to redraw that. So I got this triangle here. Maybe it looks something like that. This is 30. This is 20. And we want to know this. So here's the problem. We got 3 sides, but we have absolutely no angles. And it's not a right triangle. So we can't use Pythagorean theorem. So what do we do? Well, let's think back to this shape here. And if I'm just going to turn this diamond so that it is in square fashion or rectangular fashion here. If I turn it this way, it might be easier to see. If this is home plate and this is first, so I've twisted it, spun it this way. What angle is at each of the corners? Well, because it's a square, right? A diamond is just a square on its side. They're all 90. And since we're going on a square and cutting a square in half, we're cutting that angle in half. So that angle right there is going to be 45 degrees. So this angle from here to here is 45 degrees. So that means right here, we got 45 degrees. Now, we can use the cosine law. We got an angle and 3 sides, and the angle is in between the 2 sides. So this is a cosine law question. So let's use the cosine law to find the missing angle. So we have a squared equals b squared plus c squared minus 2bc times the cosine of a. So again, we'll label this side a. This is angle A. And then this can be side B and this can be side C. And again, this B and C don't matter after we've labeled the A. So we fill in that in. X squared equals 30 squared plus 20 squared minus 2 times 30 times 20 times cosine 45. And we can square our 30 and get 900. We can square our 20 and get 400. I'm going to calculate that cos 45 before I do this multiplication, so I don't mix anything up. Cos 45 is going to give me 7071. And then if you wanted, you could do all the multiplication. Negative 2 times 30 times 20 times 0.7071. It's going to give me negative 848.52. So I got 900 plus 400 minus 848.52. It's going to give me 451.48. So x equals the square root of that. And when I take the square root of that, I'm going to get 21.25. So looks like the pitcher's mound to first base is 21.25 meters. So in this case here, we only had to use the one formula, but we did have to break up another shape into a triangle. And in this case, we know it's not. You can't assume it's 90. It's not going to be because of the setup of this, but you can't assume this is a 90-degree angle. And then this angle inside here was, again, we knew this was 90 because it's a square. Right, a diamond is a square turned on its side, other than my poor drawing, and so that's 90 degrees. And since we're cutting the diagonal square in half, we were able to get the 45-degree angle there, and then just substitute values into the equation to solve. So that wraps it up for everything as to content.